Hello everyone, welcome back to another AP Calc video, and today we'll be going over integration with U substitution. So let's say we have an integral 3x squared, and let's multiply this by x to the third plus 5. Let's raise this to the 10th. So intuitively, you may just want to multiply these terms out. And technically, you could, right? You could multiply all of these terms out and then take the integral of each one by one after multiplying it by 3x squared using the reverse power rule. And if you didn't already, the reverse power rule, which is essentially needed for any sort of integration almost, is where you do the reverse power rule. And so instead of taking the derivative of x fourth, which would be multiplying it by the power, so 4x, and then subtracting the power by 1, so 4x to the third. Essentially what you're doing is you're doing it the opposite way around. So you're going to, instead of subtracting the power, you increase it by 1. So you have x to the fifth. And then instead of multiplying by the power, after you add to the power, you're dividing it. Right. And then that would be plus c because you can't forget the constant. Okay. So just a refresher on some basic integration. So now we'll get onto U substitution. So basically the U substitution purpose is to eliminate unnecessary terms that are preventing you from using the reverse of the power rule. And you'll see intuitively why it makes more sense as I go along. So we're going to choose an arbitrary variable. We'll call it U. Not really arbitrary considering that it's U substitution. But we'll set U equal to this term right here. And you'll see why in a second. So we have U equals x to the third plus 5. And now what we're going to do is we're going to take the derivative of both sides. And so what we end up getting is du, right? Because the derivative of u would be 1, and then that would be times the derivative constant. And so that would equal 3x squared, right? Because you bring down the 3, then subtract the power. And then the derivative of the constant is just nothing. It's canceled out. So what we have now is du equals 3x squared, but we can't forget, since we took the derivative of x, we can't forget our derivative constant dx. And so now you might be able to see where I'm going with this. So we have a 3x squared here, a 3x squared here. We know that we set x third plus 5 to u. So we can replace what we have with what we know. So what I'm going to do is I'm going to divide 3x squared both sides. These will cancel. So we get dx equals du over 3x squared. And this will work out nicely because now we can replace our terms. So we know that x to the third plus 5 equals u. So we can set this equal to u. We have 3x squared. We have our to the 10th power. And then what we can do is we can replace dx with du over 3x squared. And these are multiplied. So now we have a 3x squared on the numerator and a 3x squared on the denominator. So we can cancel these out. It's just equal to 1. And so what we end up getting is u to the 10th du. Now we have a much more simpler integration where we can just reverse the power rule in order to solve it. So let's see. U to the 10th power, we can increase the power by 1. U to the 11th, divide by that 11. And so we have u to the 11th divided by 11. We can't forget plus c as our integration constant. But we're not done yet because this was our original integration in terms of x's. So we need to convert the u back into the x's, and this isn't that tricky because earlier we set u equal to x to the third plus 5. So what we can do is just write this as x to the third plus 5 to the 11th power, right? Because we're replacing it with u, and then divide that over 11 plus c. And there is our answer. Hope you guys enjoyed this video, and if you enjoyed it, make sure to leave a comment, like, or support the channel by subscribing.